Absorption spectrum of the hydrogen atom. You have heard the name of Lyman, Balmer, Paschen, Brackett, Fund and the Humphrey series. This lies in the emission spectrum of the hydrogen atom. When the transition of the electron takes place from higher energy state to some lower energy state, then the radiation is emitted in the form of photon, and that appears a bright line. So the series that is visible to us, that is only the Balmer series. Remaining all are invisible series. This is called the emission spectrum because photon is emitted due to the transition of the electron. But if suppose electron is excited to some ground state, then it will absorb the energy equivalent to the energy difference of the two states, ground state and the excited state. Now in that case, the spectrum will not be the emission spectrum and there will be no bright line. In that case, we are getting a black line because the electron absorbs the energy equivalent to the energy difference of the two states. So this kind of spectrum, when the electron is excited from ground state to some excited energy state, then we are getting the absorption spectrum. And this is known to us that electron always lies in the ground state. So if we are talking about the hydrogen spectrum, then the electron lies in the first energy state and it is excited to the second energy state, third energy state, fourth energy state, sixth energy state. Then we are getting to this series that will start from the ground state, and this is just like the Lyman series. Since the electron is found in the ground state, so the Balmer series is absent. If initially the electron lies in the second energy state and then this is excited to third, fourth, sixth and so on, then we will get the Balmer series in the absorption spectrum. So the series will appear in the absorption spectrum if the electron lies in some excited energy state. Otherwise, only the Lyman series will be observed in case of the absorption spectrum. So what we have, the energy absorbed is equal to energy of excited state minus energy of ground state. So what we have? E equal to excited state. This is now your minus 13.6 upon N2 square minus 13.6 upon N1 square. So much. This will be so much electron volt. So for you are finding for ground state, this is now your 13.6 upon N1 square minus 13.6 upon N2 square. So much electron volt. This is now E. So now let's in ground state N1 equal to 2, N1 equal to 1. Then what will happen? This energy absorbed E equal to 13.6 minus 13.6 upon N2 square. So much electron volt. And N2 will be equal to 2, 3, 4, 5, 6 and so on. So here this N2 equal to 2, 3, 4, 5 and so on. So electron has to excite from ground state to some higher energy state. So now for first energy state, excitation to first energy state. This E will be equal to how much? 13.6 minus 13.6 upon 4. So much electron volt. So this is equal to your 13.6 minus 3, 4, 3, 3.4. And this is now so much electron volt. So E is equal to 10.2 electron volt. It means that so much energy will be absorbed by the electron. And excitation to third energy state, excitation to second energy state. Second energy state. फर्स्ट एनर्जी स्टेट कहलाएगा, फर्स्ट एनर्जी स्टेट। सेकंड एनर्जी स्टेट, हाँ सेकंड एनर्जी स्टेट इज वेरी सही, ये थर्ड एनर्जी स्टेट। So for third energy state, n equal to 3. Now, if suppose somebody says that what is the first energy state, then first energy state to the ground energy state. So this is the second energy state. First to second, then first to third, then first to fourth. 13.6 minus 9, so this will be now your 1.51 electron volt, and this is equal to 12.09 electron volt. This is equal to so much. It means that electron lies in the ground state and then it has to excited to the third energy state. Third energy state, then so much energy is required. The electron will absorb so much energy, then it will reach to third energy state, and so on. And so how to represent to this one diagrammatically? This is the first energy state, this is second energy state, this is third energy state, this is fourth energy state, and so on. This continues up to infinity. This is the ground state. Ground state. So now electron will excite to this one. This is now first excitation energy. Then to this one. Then to this one. So this is now first line, second line, third line. So these lines will be absent in the spectrum, in the emission spectrum. So corresponding to this one, we are having this absorption spectrum. So this is what the second is the this one, excitation to second energy state, first to second. So this is the first line, this is second line, this is third line, like this. So excitation will take place from ground state to so much state, and this state, this energy, this series is just like the Lyman series. Ground state. Black lines appear in absorption spectrum. So always remember that whenever we are finding the black lines, it means that is the absorption spectrum. The energy corresponding to that line has been absorbed. So now you can also find, you can also calculate the energy absorbed so much, and the wavelength of the photon you can find. This E equal to, so this is now equal to H, E equal to H nu. E equal to Hc upon lambda, then find the value of lambda. So corresponding to this second, first, third, fourth, and so on, we will find the energy levels, and we will find the photon energy. So this is now photon energy so much, photon energy so much, and then to next one. So Like this, we can find the lines in the absorption spectrum. So this is what the absorption spectrum of the hydrogen atom. So thank you very much.